Welcome to all of you. Today we will discuss the implementation of one of the famous classification algorithm, that is the logistic regression, by using Python programming.
Now we have understood the concept behind the logistic regression. Now let us implement the algorithm by taking some suitable data. So we will use this German credit data set, which is available at UCI machine learning lab, to predict whether a credit is a good or bad credit. So basically this credit classification is one of the popular classification problem encountered by financial institutions. So for example, when customer apply for a loan, then this financial institution such as bank would like to predict the probability probability of default. So basically this given data contain the several attributes of the person who availed the credit. So if you want to read and display the few records from the data set, then by using this method we are reading this data set, and now you can display it by using this command, right? Now if you see this data set basically contain 1000 entries and 1000 records are there, and 14 columns we are having. Now printing all the columns together will exceed the page width. So we will print the first 7 column like this by using this by using this iloc method. Then print the remaining one over here. So if you see this, now here basically few columns like this checking underscore account. If you see this this column, basically it is having a categorical values, and that's why it is inferred as object over here, right? So it means that if you want to use such kind of categorical data for doing a machine learning modeling, then we have to do a proper encoding of such kind of columns. So that we have to identify and we have to do the conversion. So that we will see during this data pre-processing. Now to find out the number of observations in the data set for good credit and bad credit, a simple this value count on status column will provide the information. So here with this output you may see that there are 700 observation of good credit and 300 observations of bad credit we are having. Now for building the classification model, this status column will be used as dependent variable, while the remaining column will be the independent variable, you may say features. We will create this list called x underscore features, and store the name of all independent variable for the future purpose, right? Now as I told you, many columns here are the categorical information we are having, so we have to apply the encoding on that. So here in this section we are doing this encoding part. So as I told you, severals are having this categorical information. So by using this get dummies method, we are converting it. Now this pandas method called this p.getDummies is basically used to encode the categorical feature and create the dummy variables. So if a feature has n categories, then either n or this n minus 1 dummy variables can be created, right? So if let's say this n minus 1 categories are created, then the omitted category serve as the base category, right? So basically this pd.getDummies take the parameter called drop underscore first, which drop the first category if it is set as true, right? Now we can list the new dummy features that have been created along with the other continuous features, right? So that we have listed. Now For example, let's say checking underscore account variable is encoded into 4 by using the three dummy variables and the base category, right? So if this checking underscore account underscore A11 is dropped, right? So if all the following, all this following three variables values are set as 0, right? If you see the first one, all these values are set as 0. It simply indicate that this account type is checking underscore account underscore A11, right? So now we can display all the dummy feature to verify how they have encoded via executing this statement, right? So you may see how these values are encoded. Now the first record already we have discussed, it is set as 0. So it is simply indicating this checking underscore account underscore A11, whereas the second one is indicating the account is checking underscore account underscore A12 because this value is set as 1, right? Now as the variable we have prepared now, right? Now we can set X feature and Y feature variable before proceeding to build the model. So similar to OLS method to build a linear regression model, now this stats model .api provide a logic method for building the logistic regression model, right? Here we are having this logic method, right? So that is available in this stats model.api. So now what we have to do here is we need to add new column and we will set its value to 1 for model to estimate the intercept, right? So that portion, that thing we have to do over here. Now in this logistic regression, the regression parameters are estimated using the maximum likelihood estimation. So that part we should understand, that we have already learned. Now here what we are doing, we are before building the model, we have to split the data set into 70 and 30% ratio, or maybe 80 or 20. It is up to you. Right, how you want to split the data set. So here I have done this 70-30 division. Splitting is having a 70-30% ratio for creating the training and validation data set. Now the model will be built using the training set and tested using the test set, right? So this X train, Y train contain the independent variables and response variable value for training the data set respectively. Similarly, this X test and Y test contain the independent variables and response variable value for the test data set, right? So now we will use this fit method using this logic and pass training set Y underscore train and X underscore train as a parameter. So invoking this fit method, which is available in this states model.api, this module will help us to estimate the parameter for logistic regression model. Now this fit method on logic estimate the parameters and return the model details in variable called this logic underscore model, which contain the model parameters, accuracy measures, the residual values, right? So this many information is going to be, this variable is going to be consist. Now this model object logic underscore model has a summary 2 method which provide the details of the model, its parameters and result of all necessary the statistical test. The model summary contain the important information basically to validate the model. So here, this is a detail of that. So to understand this, we have done subsequently this model diagnostic, right? So it is very important to validate the logistic regression model to ensure its validity and goodness of fit before it can be used for any practical application. So basically in this model diagnostic, this following measures are used to validate the logistic regression model. So basically we perform this wall test, or it is also known as chi-square test, for checking the statistical significance of individual features, right? So I mean it's quite similar to t-test in machine learning, I mean multiple linear regression model, whereas this LLRP, that is a likelihood ratio test for checking the statistical significance of overall model, right? So this likelihood ratio test is also used for the variable feature selection, right? Now we are having one more measure that is known as a pseudo R square. So it measures the goodness of model. It is also called pseudo R square because it is not have the same interpretation like R square in multiple linear regression. So if you see here, this model summary suggests that if you apply this wall test, so as per the wall test, only this many features are statistically significant. Because the value is less than alpha, that is 0.05, right? As a p-values are also less than 0.05. So p-value for likelihood ratio test indicate that the overall model is statistically significant. If you see over here, this is a p-value of likelihood ratio test. It is almost 0, right? So which shows that this model is a statistically significant model. Now what we are doing here, we are defining a method called get underscore significant underscore variable that takes the model object as an input, right? And return the list of significant variables after filtering out the variables with the corresponding p-value less than 0.05, right? So if you invoke this function and if you pass this logic model which we have prepared to this function, so basically it is going to return the list of significant variable, which is nothing but this one, right? Now here one thing is very much clear, this all the features which we have used for training purpose, they are not statistically important, right? So by executing this up to here we have understood that this many features are only a significant feature, so remainings are not equally important. So what we are doing here is, now I am going to be consider only this many significant features and again make the train the model, right? So hopefully by that way we will get the better accuracy model. I mean we'll get the result which is having a better accuracy. So with this assumption we are going to be have this many features only we will consider, and now we will build a logistic regression using only this significant variable. So that we did over here. Again we are making a model, but this time only the significant features we are considering. So after this execution of this statement, my model has been trained. So if you see the summary of this model, so that we are getting corresponding to coefficient, we are getting this negative sign. So this negative sign in coefficient value indicate that the value of this variable increases, the probability of being bad credit decreases, right? So if there is a positive sign, means the probability of being bad credit increases as the corresponding value of variable increases. So you may have a sum of the observation like this model. Let's say this probability of being a bad credit increase as duration, amount and interest rate increases, right? Whereas the probability of being a bad credit decreases as this age increases. This means that older people tend to pay back their credit on time compared to the youngster people. That intuition we can get out of it, right? Now we will use this final logic which we have created. So with the help of this final logic model and a significant feature to predict the class probability, we are having this predict method which will return the predicted probability for each observation in test data set. So we will store the actual predicted class and the predicted probability in the data frame to compare and calculate the various accuracy measures. So here we are printing this prediction of few test sample randomly using the sample method of data frame, right? So to understand how many observation the model has classified correctly and how many it has not, we have a cutoff probability needs to be assumed. So assume that cutoff probability is cutoff probability is, let's say, it is 0.5. Then all the observation with the predicted probability of more than 0.5 will be predicted as a bad credit, and rest of all as a good credit. Now, after this, we will find out what should be the optimal classification cutoff a little later. After this section, we will find out how to calculate this optimal classification cutoff. So here we have assumed, let's say it is a 0.5. Now iterate through the predicted probability of each observation using this map method, and tag the observation as a bad credit if probability value is more than 0.5, or as good credit 0, right? Otherwise, so that condition we have put it over here. So as a resultant, you will see the actual column here in this data frame depict the actual level of credit in the test set, while the predicted column depict that what the model has predicted by taking 0.5 as a cutoff probability value. So for the observation, let's say 557, the model predict very low probability called 0.08 of being a bad credit, whereas it is actually a bad credit, right? So this model has wrongly classified this one, but the model predict the high probability of being a bad credit for the observation called this 332, right? So here model is saying it is a 1, and our prediction is also saying it should be the 1, right? So if you see this table, and if you observe this table thoroughly, so you will notice that actual and predicted columns have some classification that's are not correct, and some of it are wrong, like 557 observation. If you see, it is completely wrong, whereas in this case 332 observation is correct, right? So for better understanding of this confusion, we can build a confusion matrix, right? So for that regard, we are using it. So this confusion matrix, it is also called as error matrix, and in some of the book you may see it is known as classification table. So it is a matrix which is found by checking the actual values and predicted values of the observation in the data set. So to create the confusion matrix, first we have to import this matplotlib.pyplot and cbon libraries to renders all the plots and charts, so that we have imported all the essential libraries. So this sklearn.matrix module provide a method to build this confusion matrix if actual and predicted values are passed as an input to as a parameter, right? So for the better understanding, this matrix can be plotted as a heat map. The cbon heat map function can render the confusion matrix for this for the easier interpretation, right? So by this define a method called draw_cm that takes the actual and predicted values, and it creates the confusion matrix, and after that we are drawing it the heat map, right? So this is a heat map of that. So simply we have invoked this method and plot the result of our model prediction. So that is the result of that. Now see, if this in this confusion matrix, the column represent the predicted label, right? It is having a predicted label at the bottom, while the rows are representing the actual labels. For example, out of this 91 bad credit, only 30 have been classified correctly as a bad credit, and the rest 61 have been classified as a good credit when the cutoff probability is 0.5. Now see, this each row represent the actual bad credit and good credit observation present in the test data set, and each column represent the predicted value of outcome variables. So here we can, we may have a certain observation. Let's say this left top quadrant represent the actual bad credit, and is correctly classified as a bad credit. So this is called as true positive, right? This left down quadrant represent the actual good credit and is is incorrectly classified as a bad credit. So this is called as false positive. See this right top quadrant represent the actual bad credit and is incorrectly classified as the good credit. So this is called as false negative. Whereas this last one, see this right down quadrant represent the actual good credit, and this one is also correctly classified as a good credit. So this is called as true negative, right? So that is how to get the observation from the heat map from this confusion matrix, right? Now based on this value, this confusion matrix value, we are having a number of measures to through which we can check the accuracy. So in classification, the model performance is often measured using the concepts such as sensitivity, specificity, precision, and F-score. Now the ability of model to correctly classify positive and negative is called sensitivity, right? And sensitivity is also known as a recall, or you may say the true positive rate, and specificity, right? So the terminology, this sensitivity and specificity basically originated from the medical diagnostics. So let us discuss about this all these measures, like sensitivity first. Let's say, so sensitivity, or you can call it as a recall. So basically this sensitivity is a conditional probability that predict the class is positive given that actual class is positive, right? So mathematically we represent it like this TP by TP plus Fn, right? Whereas this specificity is a conditional probability that predicted the class in negative given that actual class is negative. So mathematically it can be represented by Tn divided by Tn plus Fn, right? We are having a precision. So precision is a conditional probability that actual value is positive given that prediction by the model is also positive. So mathematically we will write it like a TP divided by TP plus Fn, right? We are having an F-score. So this F-score is a measure that combines the precision and recall. So basically harmonic means between the precision and recall it find out, right? So this F-score can be given by this equation: 2 multiplied by recall multiplied by precision divided by recall plus precision. So by using this classification underscore reports method in sklearn matrix give a detailed report of prediction, report of precision, recall, F1 score, right? So if you execute it, this is the value you will obtain. So this is an important observation here. So this model is very good if you observe it. So this model is very good at identifying the good credit. If you see here, this is beautifully it is identifying the good credit, but not very good at identifying the bad credit, right? So that this has happened. The reason may be the cutoff probability, because we have assumed it as a 0.5. So this can be improved by choosing the right cutoff probability, right? So that is something which we have to understand over here. Now we can plot the distribution of predicted probability values for good and bad credit to understand how well the model can distinguish bad credit from the good credit. So for that regard I have plotted it. So we can use this chart to understand how the distribution of predicted probability for bad credit and the good credit look like. So if you see this graph, so this larger overlap between predicted probability for the different classes, higher will be the the chance of misclassification. So that is the intuition out of this graph. Now we are having this ROC and AUC measures. So this ROC is receiver operating characteristic curve, and it can be used to understand the overall performance of logistic regression model. So, and it is used for model. So basically, as we were discussing about this ROC, so ROC is used for the model selections as well. So the term here is basically came from the electric engineering, when this electrical signal were used for predicting enemy objects, right? So at that time, during the World War II, this term was initiated. So basically, this this ROC gives the proportion of such pair that will be correctly classified, right? So that is something which ROC gives us. So ROC curve is basically a plot between sensitivity and vertical axis and 1 minus specificity on the horizontal axis. So we will write a method, let's say called draw underscore ROC. Basically, it takes the actual classes and predicted probability values and then draw the ROC curve, right? So here we are having this metric dot ROC underscore curve, return the different threshold. That is nothing but the cutoff values and their corresponding false positive and true positive rate, right? So then these values can be taken and plotted to create this ROC curve, right? So if you will see this diagonal line, so this represent the case of not using a model, right? The area below the diagonal line is it is a 0.5. Whereas this sensitivity or specificity are likely to change when the cutoff probability is changed. The line above this diagonal line captures the how sensitivity and 1 minus specificity changes when the cutoff probability is changed, right? So that idea we can have from here. So basically, a model with the higher AUC is preferred, and the AUC is frequently used for the model selection, right? So as a thumb rule, this AUC should be at least 0.7 is required for practical application of the model, right? So AUC greater than, let's say if it is more than 0.9, it simply implies that the model is an outstanding model, right? So here one thing, we should be very careful to exercise while selecting the model based on the AUC, especially when data is imbalanced, right? So in case of imbalanced data set, AUC may be very high, right? However, their sensitivity and specificity value may be poor. So that is a thing which we have to observe thoroughly. For example, in our case, AUC value is coming as 0.78, which implies that our model is fairly good. Now the AUC can also be obtained by using this method, right? We have to call this method matrix dot ROC underscore AUC underscore score, right? This is a present in sklearn.matrix module, right? Now the concern is, this is result we are getting when we have put the cutoff probability as 0.5. Now we are having certain methods where by using which we can identify the optimal cutoff probability. So those methods are, we are having basically two methods. One is by using Youden index, and we are having another method that is called as cost-based approach. So by using this approach, we can find out what should be the optimal cutoff, right? So basically this Youden index, we check the sensitivity and specificity. So this sensitivity and specificity changes when we change the cutoff probability. So Youden index is a classification cutoff probability for which this function value should be maximum, right? So that is the idea. So Youden index, and we define it like this. Now we already know that sensitivity is also known as a true positive rate, and specificity is known as true negative rate. So that's it, means the select the cutoff probability for which this TPR plus TNR minus 1 is a maximum, right? So by using this draw underscore ROC, this method, draw underscore ROC, actually it is returning this TPR and FPR value, which we have to store in variable called TPR and FPR respectively. This the variable threshold capture the corresponding cutoff probability. So we can take the difference of TPR and FPR and then we can sort them in descending order, so that we have done over here. So this TPR FPR we are taking from there, and we are finding out the difference between TPR and FPR, and then we are sorting it, right? So once we display it, so this is the outcome of that. So from this result, if you see, the optimum cutoff value is 0.22. So we can now classify all the observation beyond 0.22 predicted probability as a bad credit and others as a good credit. So we will capture this new class in this predicted underscore new variable, right? And then draw a new confusion matrix. So if you draw the new confusion matrix, so this is the outcome of that. So this is the, we are printing the report with the cutoff probability is equal to 0.22. So this is the result of that. So you may see here, with the cutoff probability 0.22, the model is able to classify bad credit better, and F1 score of for bad credit has also improved. So if you compare this model with the previous one, so you may see here we are getting the better result, for particularly for the bad credit, right? So these values are better than this one which we have obtained earlier. So it is over here, right? So that is that comparison you can do, right? So this selection of cutoff value is very much very important part. So by selecting the good cutoff, obviously we have seen that results are getting better. Similarly, we are having one more approach. That approach is known as cost-based approach. So as the, again, this approach is again help you to find out the optimal cutoff probability. So here the concept is, as the cost of false negative and false positive is not same, they are having different weight, right? So with this understanding, this approach will work. So in the cost-based approach, we assign the penalty cost for misclassification of positive and negative and find the total cost of the cutoff probability, right? So that is the idea behind this cost-based approach. So assuming the cost of false positive is C1 and the false negative is C2, then total cost would be this much, right? So the optimal cutoff probability is 1, which minimizes the total penalty cost. So that is a fundamental idea behind this cost-based approach. So to create a data frame which will capture the cost against the different cutoff probability value, we have created it. So that the cost-based data frame we have created over here. Now let us assume that false negative are 5 times costlier than false positive. So deciding the cost which require the basically the domain knowledge. So here we can calculate the penalty cost for each cutoff probability values between 0.1 and 0.5 with the incremental value of 0.01, and we are sorting, we sort the cost in ascending order to find the cutoff probability at which penalty is the minimum, right? So you may see over here the lowest cost is achieved at cutoff probability of 0.14, right? 0.14. So if false negative are assumed to be the 5 times costly operation than the false positive, right? So let us predict everything beyond 0.14 as a bad credit and below 0.14 as a good credit, right? So if you again, based on this threshold, if you train the model and if you draw the result, so you may see here the model has reduced the false negative to only 6, right? Only 6. This is because the high cost 5 negative, that is 5 times compared to the false positive. Now the number of false positive have increased to 120, right? So based on this model, if you will draw the outcome of that, you may see the precision here is getting better. Recall values again we are getting better than the previous model, and F score is coming as 0.58.
Now let me summarize this entire discussion. So basically here we have used the concept of confusion matrix. So basically confusion matrix is a table of data that summarizes the performance of a machine learning model. It helps to know where the model is performing well and where it is failing, as well as confusion matrix is it is created from the confusion underscore matrix function of the sklearn.matrix module. Also this confusion matrix is drawn as a heat map in a Seaborn package. Basically this logistic regression model is used where the output represent a class or a category. There are basically two type of classification we are having. One is a binary, so another one is a multi-class classification. So in binary classification, the output basically represent one of the two classes, whereas in multi-class classification the output represent one of the multiple classes. So we basically represent the logistic regression by using the S-shaped curved line formula, and that is equal to 1 by 1 plus e to the power minus mx plus b, where mx plus b indicate the formula of a straight line. Thank you.